Hello friends, you may recall that we have discussed several aspects of air quality monitoring and then modeling, emission inventory development, and these days we are discussing about several kind of emission inventories, whether for industrial sector, transportation sector, domestic sector, etc. Today we will discuss about the application of remote sensing or satellite based data in air quality management. So, in air quality management means this can also help in developing like emission inventories or other issues. So, this lecture will constitute of these particular classifications or content list, like we will discuss first of all what is remote sensing, okay, and then satellite remote sensing, what is the need of satellite based remote sensing data in air quality management, and what are different products of satellite based remote sensing observations, and then how do we apply these remote sensing data in transport emission inventory or agriculture emission inventory or industrial sector emission inventory. Then we will also see that how these remote sensing based data can be used for predicting PM 2.5 concentration, that is particulate matter of 2.5 micrometer size, and using this aerosol optical depth, which is a technique AOD, aerosol optical depth. Right. Then we will see what is the way forward, that means what are new things which we can do with the help of satellite data for better air quality management, right. So, like when we go for the introduction of remote sensing, the remote sensing itself is an art and science of collecting information about the earth surfaces. Okay. There are so many features of the earth surface and various phenomena like atmospheric phenomena or water sets, air sets, etc. But today's lecture is basically concentrated on atmospheric constituents based on remote sensing data. So, we will focus on these particular aspects of the atmosphere, which is monitored using some sensors without physical contact with the surface of the earth or with the phenomena, whether like air pollution, plumes are there. So, without any contact with that, like a physical monitoring system has some sort of instrument which has physical contact, then they measure, but in remote sensing only sensor based data observations are there without physical contact. So, if we want to understand how does it go, like what do we do in remote sensing, basically the fundamental concept can be understood with this pictorial representation, where this illumination or the energy source is from the sun and the solar radiation comes and the surface absorbs some part of it, then it reflects some part of it. So, you can see at the point C, this is the interaction target of the solar insolation, then it reflects, okay, then it goes up to the satellite, right. So, the recording of the energy by the sensors are there in the at this place, and then transmission of and reception of processing these data can be through several other instruments which are part of this. At last we interpret or analyze these data with the help of computers and techniques, maybe some statistical tools, plotting the graphs, tabulations, etc. So, that way we apply and use that information for whatever purpose we are getting this data, like this lecture is for air quality management. So, we will see how do we use these products of remote sensing or satellite for air quality management. So, this satellite remote sensing of troposphere, which is the lowest layer of the atmosphere, is rapidly developing in all over the world. Basically, this field is very increasingly it is going on in a developing phase. So, satellite sensors in the Earth's orbit that can measure trace gases as well as particulate matter or aerosols and their properties relevant to air quality, whether their concentration and their other aspects. So, also like sandstorms or forest fires, biomass burning, industrial emissions, all those plumes can also be traced by satellite observation. So, this is several uses of the satellite products. Well, when we talk about what is the need of satellite remote sensing data in air quality management. So, basically this provides a vast geographical range and the wide spatial resolution across a region that is not possible through conventional air quality monitoring, because we have limitations in terms of resources, in terms of human resources, otherwise financial resources, because it needs lot of instrumentation, etc. But this way it can cover a lot of geographical region which requires lot of investment if we go surface monitoring kind of network, right. So the satellite monitoring can also help in determining like columnar profile of a pollutant, like CO profile in a column or ozone or other like, and then also possible long range transportation of plumes, like when forest fire is there or from thermal power plants, plumes are going because of some atmospheric phenomena, it can go up and then go that can transport it in downwind direction. So it can trace, this satellite observation can easily trace, and it can give a good spatial distribution of those plumes and these air pollution concentrations. Well, then in context of India, basically if we talk about what is the air quality monitoring network density in different countries, then ours is kind of lowest one. You can see here only 0.14 number of monitors per million of the people is there in India, whereas in China it is 1.2, in USA it is 3.4, in European countries it is 2 to 3, and Brazil 1.8, Japan 0.5. So we are the lowest one in that case. So we need lot of other ways of information, and satellite information can really fill this gap, which is because of limitations through surface monitoring. Well, when we talk about satellite based data products, so there are many, like monitoring implies evaluation of different parameters such as aerosol optical depth AOD and gaseous columnar volume densities, which are then converted into some particulate concentration values and gaseous emissions values in that form. And the monitoring products can be used to calculate or estimate long range trends in pollutant concentrations and to develop emission inventories also for major sources of air pollution in a particular given area. So these are the uses of these basic products. And when we talk about these satellite monitoring products which are available to India, these are like you can see for different periods and the domain, like aerosol optical depth, ultraviolet or aerosol optical depth, aerosol index, aerosol layer height, aerosol profile. These different products or parameters are there which are available for different periods. From 2000 onwards, a lot of information is available. Some are latest one like 2019 to present, carbon monoxide total column, which is from the satellite 5P of European Space Agency. So different agencies are there, like ISRO from India, then NASA from USA, and European Space Agency is there. So several data are available or products are available. In Indian context, we can use all these kind of parameters basically. So this table gives the information about the these atmospheric products which are related to pollution monitoring in Indian context. Okay, and these most satellite data basically draw inferences on India's air quality from satellites which are not launched in India, like from USA, from European Space Agency, but we have collaborations and we can get those data. Now when we talk about what is the application of these remote sensing data in air quality management, so there are many, like this list shows, like it can help in air quality forecasts. Okay, those data can be used in that way. Then it can also help in improving characterization of surface layer air pollution information. It can also improve the emission inventories and incidental releases from particular sources of some pollutants. Okay, monitoring of air pollution data, validation of models, like because it will give additional information. So the validation which we do from generally from these physical monitoring sites available data, this can also help in validation, right. Then identification of air sheds in different ways, like this air shed is more polluted, this is less, particular pollutant is there in a particular air shed. So this can help in that way also. It can also help in demonstration of episodic pollution which happens once a while, not always, right. Then inspection of consistency or consistently these non-compliant sources we can have with these kind of data. So there are multiple applications basically. When we talk about like how to apply the remote sensing information in transport emission inventory, transportation sector, so there are some information which are very interesting, and you will find it very informative also. Basically the remote sensing data can determine emission rates for whole fleets and even for specific vehicle types and vehicle classes with some emission instruments like Euro 1, Euro 2 or Bharat stage 1, Bharat stage 2, like that. Okay, if sufficient data are available, then distinct vehicle makes and those models, those related emission profiles can also be created with the help of this remote sensing data. So, the remote sensing or RS technique, which measures exhaust emissions from the tailpipe by absorbing some spectroscopy with the absorber spectroscopy technique without interference with the vehicle, means vehicle is moving and without coming in contact with any other things, or without talking to the driver, or without interfering in driving. The driver is taking its vehicle without talking to any other person, and the remote sensing technique is capturing that information, what is the pollutant stream from the tailpipe, right. So, the sources and how does it happens, basically how it is measured. So, the sources of infrared or ultraviolet light from a particular instruments can be put like across the road, right. You can see here. So, this light are placed next to the road with their beam directed across the road. So, when some vehicle will pass, it can penetrate through those plumes or the emission streams. At the height of the vehicle it is kept, so that the pollution capture is proper at the tailpipe or exhaust plume. The light is reflected back by a mirror located at the other side of the road and focused into a detector. So, that way this light intensity gives the indirect information of the pollution. So, the measured this reduction of the light is directly proportional to the concentration of certain pollutants in the atmosphere in that particular area, and these pollutants come from the exhaust of the vehicle that has just passed, right. So, as well as from the background presence of the species of the air pollutants in the ambient air. So, therefore, the pollutant concentration that was measured before the vehicle crosses that particular light beam and then taken after the vehicle crosses. So, the difference is given, the difference of that particular concentration gives how much pollution has been released by the particular vehicle, right. Then the remote sensing instruments, this configuration, how does it take place? This is also shown in this particular figure. You can see there are 3 units. The first unit measure the vehicle emissions by absorption spectrography. You can see here this one. The second unit measures the speed and acceleration of the vehicle, and the third unit reads the this number plate of the vehicle. So, with the help of number plate of the vehicle, we know how much how many years old this vehicle is, and there are many other information which can be taken from that particular repository which is available through ITO, this RTO office. Okay. Now, if we talk about like application of remote sensing in transport emission inventory, then this technique has been further improved. Like rather than putting the instruments across the road, now these instruments are placed at the certain height. So, it gives this beam, and the laser is used better for better capture of the information. So, that can have this particular information across the road, plus there is a stripe which can reflect this light of the laser light. So, the laser beam is used and the information is captured for the whole plume which is being emitted by the vehicle. So, that way accuracy is better in comparison to the other technique. Okay. So, the laser is used as a source and making the measurement more selective and precise to the pollutants in that way. Okay. So, you can see here this the first light source and detector are mounted above the road in this particular configuration. You can see then the laser light is scattered back from the reflector strip. This is reflector strip you can see on the road, and then exhaust plume is captured entirely because of that particular this arrangement. Well, when we talk about the pollutants measured using remote sensing techniques, then we see that the instruments which are measuring the pollutants are based on absorption band, okay, of a spectrum, particular range is there. Then non-dispersive infrared NDIR component is used for detecting like carbon monoxide or CO2 or hydrocarbons, and twin dispersive ultraviolet spectrometer is used for measuring the oxides of nitrogen like NO and NO2, and also SO2 and ammonia. So, that way difference is there. Well, there are certain limitations of remote sensing in transport emission inventory, because this remote sensing works most accurately under slight acceleration, not very high acceleration, and not even when this vehicle is at idle stage. So, the emissions during idle and deceleration are not captured. So, little acceleration must be there, then it gives the good reading. Then measurements are more difficult when raining is there or surface is the wet, again then accuracy is not good. Okay, then vehicle technical data are taken from the registration database. As I said, when this number plate is captured, then from that repository, from the RTO office, we get the information. So they record the technical features of the vehicle when it is new, and but there is no data that how much it is being repaired, how many times, or what is the stage of its maintenance. Those kind of things are not available. So some uncertainty may be there in that particular data. Well, if we come to application of remote sensing in agriculture emission inventory, because transportation is over now, we go for agriculture burning related inventory or the data. So the satellite measurements, which are generating images with the help of like identifying locations and count of different fires which are taking place at the forest level or even agricultural fields, and the values which come from a crop residue monitoring exercise using this moderate resolution imaging spectrodiometer radiometer MODIS, okay, and visible infrared imaging radiometer suite like VIRS data. So these undertake by the consortium for research on agro ecosystem monitoring and modeling from space. This is known as CREAMS. So that way, it is a well established, well managed program through this CREAMS agency consortium. So this is an interdisciplinary research initiative of Indian Agriculture Research Institute IARI in New Delhi, and it is coordinated by Division of Agricultural Physics basically. So the CREAMS operates its own excellent band satellite ground station and receives the direct broadcast remote sensing images and a range of international site. These satellite these constellations are also there. So lot of information inflow is there. So basically like this has a portal, geo portal interface. So it is shown just to give you a kind of feeling how does it work. Basically there are geo portal toolbar, layers panel, okay, and the map window you can see. So you can select particular area and then you can see how many points are there of the fire burning events or agriculture burning. So you can count them, and that way information can be drawn. But there are limitations, like despite the high confidence level of fire counts data, fire counts derived from satellite are not restricted only to crop residue burning, because even if some waste burning is there, it will count some crop residue burning kind of thing. So uncertainty is there, and the interpretation depicts largely if not entirely associated with the crop burning. So that way, as I said, because it will also count other kind of burning which is not the real crop residue burning. So that way we have to be little bit careful. Now next we talk about like industrial emission inventory, what is the role and application of this remote sensing. So basically like coal combustion in thermal power plants and for domestic use in a major air pollution sources in India can be taken with satellite observations also. Like NO2 emissions from thermal power plants can easily be estimated using this particular Tropomy. This is nothing but tropospheric monitoring instrument. So this can be used for NO2 data product, and the satellite data which is used independently to track TPP emissions in India where in situ emission data are not readily available. So that way it can again bridge the gap or fill the gap. Well, the Tropomy data which are available on board, they have this sun synchronous and low earth orbit satellite related data which contains 4 spectrometers. 3 of them are used for ultraviolet near infrared range kind of thing, and the 2 spectral bands are there. One is for the this short wave infrared, okay, and it makes daily global observations, right, and it can be used for these ozone, NO2, SO2, CO, CH4 and then HCHO, cloud and aerosol properties with 2600 kilometer, that kind of area it can easily cover, overlapping this equator, and approximately around 1330 local solar time is there when it gives the data basically. Well, you can see how does it give the data about these thermal power plant plumes. So like due to high spatial resolution like pixel 3.5 to 2 square kilometer is there. High signal to noise ratio is also there. It is easy to distinguish individual NO2 plumes, like you can count here, and from specific sources such as thermal power plants. So in that particular picture, basically the spatial distribution of this columnar NO2 over northern India in 2019 was observed, along with the locations of 9 coal fired thermal power plants. So this high NO2 is visible in these particular locations. Well, there are limitations again in this case also. The retrieval accuracy may get impacted due to the presence of clouds. So then that observation is not very accurate in that sense. The accuracy of the wind data, presence of other NO2 emission sources like brick kilns, which can be mistakenly taken from the stack as the thermal power plants, industrial complexes and high traffic density, there can also be source of NO2 because of these exhaust emissions from traffic. So that kind of interference may be there, which we need to remove. Well, when we talk about like how to apply remote sensing for predicting particulate matter emissions, so then again we can go for usage of this MODIS data, moderate resolution imaging radiometer, okay. And then this earth observing system is there, US aqua satellite, which gives the information about that, and it provides numerous aerosol measurements including aerosol optical depth, AOD, okay, which can be used for reflecting fine particulate loading, etc. In 2011, an advanced algorithm was developed. This is known as multi-angle implementation of atmospheric correction, that is MAIAC, which was presented providing a set of AOD, okay, aerosol optical depth product, which with finer resolutions 1 by 1 kilometer by 1 kilometer. Earlier it was 10 kilometer by 10 kilometer. So that way this resolution related preciseness has been enhanced over the years. Well, when we talk about AOD or aerosol optical depth, so the optical depth expresses basically the quantity of light removed from a beam which is being scattered or absorbed by aerosols during the its path through the atmosphere. So that amount gives indirectly the aerosol optical depth related quantity, and these optical measurements of light extinction are used to represent aerosols, particulate matters amount in the entire column of the atmosphere. So that is why we call it columnar values. Well, so AOD is the column integrated value basically in the column, not at the particular layer. And this optical measurement of aerosol loading, AOD is function of the shape, it is unitless, shape, size and type of number of concentrations of aerosol. So that way it can vary from place to place. Then PM 2.5 monitoring at the ground, mass per unit of volume of aerosol particles less than 2.5 micrometer in diameter surface. So measurement can be done with the help of these satellite based observations also. Then there are certain like light related values. So how to convert it into concentration of particulate matter. So this is the relationship like empirical relationship which is used for concentration, for estimating concentration of particulate matter by this AOD which we have measured. So the AOD is multiplied by this FPBL and HPBL. This is nothing but percentage of AOD in planetary boundary layer and the mixing height, and we also have this particle density and the effective radius of the particles, and this extinction coefficient Q is there. So then this concentration can be calculated by this relationship. So according to this RE effective radius, size distribution, we can get calculation for different kind of sizes of the pollutants. Then this kind of pictorial representation can be there which can give how much pollution is there. For example, this high concentration of pollution in orange and red is shown, and the cloud images are also there. Then the low values of the blue which can be seen because of this kind of pictorial representation, and the vertical bars in various color denote the PM 2.5 air quality by the EPA category. Different columns you can see, these are the PM 2.5 concentrations. Well, so what is the way forward of these satellite observations which are growing day by day, and in different ways we can get the information. So the NCAP, which like National Clean Air Program, it has the intention or the objective to use satellite data for both monitoring as well as forecasting of air quality. and the action points for satellite applications as well as the associated agencies and timeline are shown in this particular table, like domains monitoring of the crop residue burning, air quality monitoring network, air quality forecasting system. So up to 2019, this was placed into action point, like coordination with ISRO, remote sensing monitoring data for crop burning by the farmers, this Ministry of Environment, Forest and Climate Change and Central Pollution Control Board, they made possible for that particular air quality monitoring network. Up to 2024 target is there. All these state pollution control boards, Central Pollution Control Board, ISRO and Space Application Center, they are joining hands to develop the capacities for strengthening the efforts for development of indigenous satellite based products and techniques for estimating particulates and gaseous concentrations in the atmosphere. And then when we talk about air quality forecasting system, then the satellite data available through the satellite network of ISRO to be integrated for monitoring and forecasting, and IITM Pune, that is Indian Institute of Tropical Meteorology Pune, and under this Ministry of Earth Sciences and the Central Pollution Control Board, they are collaborating, and by 2022 this will be taken into account and it will be properly implemented. So we can see that these satellite observations or remote sensing kind of things are integrating into the real air quality management efforts which are being made by different government agencies in India. And I look forward that because of these integrations, more efficient air quality management will be able to be accomplished. So this is all for today. We can say that this satellite remote sensing provides complete and synoptic views of large areas in one image. So that is the beauty of this satellite observations, which is not possible by point to point air quality monitoring of the data, physical monitoring of the data. Then remote sensing can also augment or increase the ground monitoring and air quality forecasting, which mirrors findings from earlier studies both at the global and national level. So that way it can strengthen those kind of efforts, and using satellite data it can be used for strategies like region specific approaches, or it can track the progress systematically and transparently, so that there is no more big chances of big errors. That kind of things can be done by the application of remote sensing data and satellite based products. So this is all for today, and these are the references for additional information. So that way we have completed the emission inventory related lectures, and now we will see other things through case studies, etc. So thank you for your kind attention, and see you in the next lecture. Thanks again.